Hello everyone, this is Mr. Appel, and we're going to look at some special cases with compound inequalities. So let's say you solve a compound inequality with an and you get an answer like this: x is less than 3 and x is greater than 6. So let's just stop for a second and think about that. Can you think of any numbers that are smaller than 3 and greater than 6? Neither can I. Now what does this look like on a number line? If you're looking at this on a number line, the numbers smaller than 3 would be those numbers. The numbers greater than 6 would be those numbers. But remember, for an and situation, we're only interested in the overlap, in all the x values that satisfy both, which would just be the overlap of those two parts. But there is no overlap of those two parts. They don't overlap, and so in this situation, there would just be no solution. There are no numbers that are both less than 3 and greater than 6. Okay, let's look at another situation. Sometimes the inequalities wind up pointing in the same direction. Like in this case, let's say we have a solution of x is greater than 3 and x is greater than 6. So if we picture what that looks like on a number line, here's all the numbers that are greater than 3. Here's all the numbers that are greater than 6. So where's the overlap? The overlap is simply the numbers that are greater than 6. And so the solution to this compound inequality actually ends up just being x is greater than 6 in terms of an inequality. And then, of course, in interval notation, that would be from 6 to infinity. So it's a little strange, but again, when you've got inequalities pointed in the same direction for a compound inequality, things behave a little differently. But again, if you always think about what does that word and mean, it means we're looking for numbers that satisfy both things, greater than 3 and greater than 6. And those are just simply the numbers greater than 6. One more case here is an or situation. Let's say we have this solution, so x is greater than 3, which is all the numbers greater than 3, or all the numbers less than 6, which is those. Well, can you think of a number that isn't either greater than 3 or less than 6? Well, neither can I. And think about the possibilities. If I pick a number out here like 8, 8 is greater than 3, so it's one of those, so it satisfies it. If I pick a number in between, it's both, so it's certainly at least greater than 3 or less than 6. If you pick a number down here that's smaller than 3, it's not greater than 3, but it is less than 6, so it also satisfies that compound inequality, because for an or, the key is you just need at least one to be true. And so in this case, every real number satisfies this. So on the graph, you would shade in the entire graph. And in interval notation, your solution would be all real numbers, or negative infinity to infinity. That's all for now. Thanks.